Good, good afternoon, everybody. We're back with another video, and we're going to be going over Tropical Low 10U, which is what the Bureau of Meteorology of Australia has marked. Not now, actually, they've marked it a couple of days ago. But we'll be going over its evolution, its potential chances for development, and what we might see over the next 5, 7 or so days. And what may be interesting in particular is its interaction with secondary low 11U, which has also been marked. And as you can see, they kind of get close together from Saturday or Friday, really. And they get closer, and they do end up being around generally the same area as they interact. That's if they both really develop. We'll be going over which low could be dominant and all the evolution specifics which will be associated with these two particular tropical lows. At the moment, we have 10U as active right now, and we also have it tagged as Invest 90S by the Joint Typhoon Warning Center on the ATCF Automatic Tropical Cyclone Forecasting System. We can currently see its structure right there convectively on infrared, and it's been marked fairly recently, so it's only been marked earlier today, Zulu time. And at the moment, we can see that there is some sort of weak low-level turning, really, which might be a bit better visible as we take a look at the low-level kind of cloud pattern that you can also see here. So you might see a bit of an elongated, weak, low-level circulation kind of there. Probably something like that, if I'm not wrong. Yeah, that's kind of what it seems to be. We'll check if there's any new advanced scatterometer data, which we might be able to use to evaluate structured low-level circulation. But for now, let's use the available conventional imagery that we have. So, let's take a look at shortwave infrared, which will give us a better insight to the low-level cloud pattern. And as we can see here, very, very evident kind of turning on the north side from north to south. That kind of rotation there, very evident. I'll mark it for you guys to see. So it generally goes like this. As we can see, kind of visibly elongated. Under a very organized, scattered, weak kind of convection with no particular structure in mind, from what it seems. Nothing really that stands out noticeably. Maybe a weak band generally there, but that's really it's not much. It's all particular disorganized, no particular solid structure. So at the moment it is in its early development stages, where it is noticeably trying to develop its low-level circulation, but it will need to get to the convective structure later. Now this is kind of what we have right now. In terms of its development chances, we'll look into why some of these may be set, but so far 10U may appear to be a possible dominant system out of the interaction between 11U, or 10U and 11U. The Bureau has given it a 25% chance of development, though it should be noted that their standard of tropical cyclone classification is much stricter than the standard American National Hurricane Center, Joint Typhoon Warning Center classification standards, where your standard tropical cyclone classification in the Southern Hemisphere from the Joint Typhoon Warning Center, well, I'll just call it the JTWC from now on, they require gales to be present with some organized convection and a well-defined low-level circulation, while the Bureau, the BOM, they require gales to be present more than halfway around the low-level circulation, or they'll automatically recognise that with a T3.0 Dvorak classification when they end up getting there. That's automatically assumed to typically that's automatically assumed to have the system at 3/4 gales at the very least, and that will allow it to be classified finally officially as a tropical cyclone. The conventional standard, mostly around the world, is following closer to the American standard, so we're going to assume that, and therefore what I want to make sure and make clear is that these chances might be biased low in terms of actual formation. These chances might be closer to accurate if following the BOM standard. So just thought I'd let you guys know. And then the same goes there, 15% chance for the secondary low. Now I want to show you guys the lows on the models in particular, for you guys to take a look. So this is the latest run that we have from the American GFS. This is 10U. That's what we're looking out for. And you can see it slowly consolidate, very slow consolidation, but we'll get to why. You can see it's a broad, semi-elongated low, very weak, no concentrated vorticity, and then what appears to be on the American solution now is that this is 11U as it kind of tracks along, this kind of area, and we can see that this low appears to be dominant. We see that within the broad monsoon trough that we see here, it does develop, a secondary low develops, and because this low is not strong enough and appears to be quite weak and diffuse, it ends up being absorbed into a developing system here. Now, because of its location of development, we could probably assume that induced coastal convergence, generally where it's located along the sea, kind of the where it's located here, that convergence may have been increased, and vorticity may have been able to subsequently increase, and therefore we get rapid tropical cyclogenesis along this area of water. That's why we see such rapid development here. We must also know that the GFS is typically very reactive to whenever there's large chunks of vorticity, and there's a lot of factors enhancing it. It will rapidly develop, sometimes unusually quickly, and it does develop. Now, this is less so what's predicted by the BOM, but we can see it develop there, and then it makes its way along the trough, but it then also, it's very erratic, and if it does move over land, moves over water for a bit, but its overall land interaction keeps it very broad, and then it eventually does get steered southeast. So this may only be a short-lived tropical cyclone if following the American solution. But let's see what the other models have to think, because for the most part, what I've noticed over the past few days while looking at this is that it's an outlier, and there are other solutions. For example, we see obviously the low here, 10U, on the European solution, on the European model that we have for 18Z, and typically we see same kind of evolution that at the beginning the Americans showed, but then instead of having a full kind of one dominant particular system, we have obviously a very noticeable development in the monsoon trough here, with the low still there. Now what happens is, this monsoon trough will have some developing vorticity, no coherent low, but developing vorticity in the monsoon trough, and then it essentially, the low is just there simply, and this kind of monsoon trough, enhanced monsoon trough pattern that happens simultaneously, it just merges, it just wraps essentially into into the system and broadens it out, but 10U stays dominant. It's the coherent low that does still exist, with no other secondary low really developing alongside the monsoon trough, along the monsoon trough. And yeah, it's a very broad system, very broad, very expanding, multiple lobes and areas of vorticity you can see there. That would not be tropical cyclone by any standard. Also a monsoon depression, sorry, that typically happens in North Indian Ocean and the Western Pacific. You see a very broad system. That's another particular solution. Lots of fail modes that come with this, obviously, as we're seeing. Very complex kind of setup here that we're seeing. Should also note that the end of the monsoon trough, gear does end up spinning up another particular disturbance. This may be something to watch out next week, particularly because there is a semi kind of favourable environment for this kind of area of vorticity to develop. So we'll look into that later, perhaps. But yes, 10U, very broad system, as it ends up having the monsoon trough wrap essentially into it, and kind of sort of merger of vorticity essentially happens. It broadens out with its influence. Now, we'll go into the kind of less reliable models. Here's another particular solution that could happen. Large monsoon trough becomes evident. Obviously, you've got your 10U. Weak system that fails to consolidate in the first few days. Large enhanced monsoon trough. But similar to the European solution, expands. System generally becomes way larger, expands, and you have the monsoon trough essentially wrap into it. But it does eventually organise enough to have plenty of vorticity. Despite it being large and of large size, we can see that they're very nice, concentrated vorticity. That's more like a tropical cyclone structure. So we can see the setup overall, while it does broaden out, and the monsoon trough does wrap into it, this will not be the end of tropical cyclone development, but it will slow down the process, despite the conditions atmospherically maybe being a bit more favourable. Interesting little vorticity there that comes out from the west. May have been a short-lived tropical cyclone on this run, particularly. There is no particular coherent signal from the main models to signal any development to do with this further west. We won't look into that. But what's also interesting is that alongside this monsoon trough, we get a bit of an earlier genesis of a particular disturbance here, similar to the one that the European solution ended up showing on the tail here. Again, as I said, this may be something to watch out for, maybe late next week. The only problem it may have is the Cape York Peninsula there, which may cause a bit of a problem, but still some potential. We may see the Bureau mark this in the future. Now, let's go over the synoptic steering setup that we have. So we'll begin with the ensembles actually. We'll look at the ensemble kind of pattern here. So, broad, low, broadens. Main steering factor, so overall what we have here, and we'll be able to see here as well, is that generally very erratic for both systems, if anything. 10U really stays in the same kind of spot, just off the coast of Western Australia. That stays up there, really doesn't do much, and then it heads southwest once it obviously ends up engaging within the monsoon trough and interacts with 11U. we can establish that to be as a result of a very dominant subtropical ridge, which is over just south of West Australia there. We see here, barely seen there, that's your low, that's 10U right there. Kept in check with this dominant ridge pattern over Australia. The broad low strengthens, intensifies. This system, this high pressure system that we have here, the ridge, very dominant again. Keeps being dominant, very large, expands even over much of the, really much of 2/3 of Australia really. And that stays there, very erratic track, stays there for around 5 days or so. Before that ridge ends up kind of moving westwards, but that also allows it to move westwards. If we go to a broader Indian Ocean pattern here, we'll be able to see that this ridge is, it's not as blocking. It allows it to take more westward motion. Which it does later on. Now, it will be a slightly different with the American solution, given that there is a different low that's dominant. So we'll go back to the Australia view. And we take a look here. And yes, you got that dominant ridge pattern that does become established over much of Australia for many days, really. And, you know, regardless, it will keep that system in the same general area for many days as this ridge pattern stays dominant. But as a low ends up moving northwards off the coast of New South Wales there, I think I drew that a bit wrong. That's the general movement. As we see this kind of movement happening there with this low and its kind of force increasing, we see that there leaves a gap for a interaction with the trough, which subsequently, as it broadens out and its influence kind of gets a bit bigger, we see that that leaves a window for the low to move southeastwards, like previously shown, into the Australian continent, or into the Australian mainland, and it's pulled towards it. So, what we can infer from this generally is that the more westwards there will be more domination by the ridge. So, a more westward solution, similar to the CMC and the European solutions, if they stick around there, this ridge blocking will be stronger, more influential, and it will be forced westwards away from Australia, or at least further away from kind of the core area of Australia, really. So this is what we're looking at with the European and Canadian. Well, I'll label it as EC, and then your GFS solution here, the American, and its associated ensembles, probably, I should probably take a look actually. I believe the ensemble, does, yeah, it's a bit split, but overall, can see strong members there around. Regardless, it should be fairly prevalent regardless that the further east that you are, here for example, the American solution, this will have more influence. This is closer to that, and there will be more influence, and hence you have a southeastward movement later down the line, past the 7-day period for the GFS, with its tropical cyclone genesis that occurs over further northeast. So that's your steering setup. That will be around for the next 7, or just over 7 days. With intensity prospects, I want to first take a look at the upper level pattern. I think the ensembles again will provide a better view at this because deterministic provides one solution, ensemble members provide one solutions. If we take everything into account, we'll get a general pattern overview, which will be helpful to give a more general idea, especially further out where we cannot rely on one particular solution. So here's a GFS solution. So as we see, there is, let me know, you see this low here, that's your dominant low. This will be 11U if it becomes a dominant low. And this upper level pattern, very divergent. We see that outflow spreading in many directions, even that way, as a kind of, I would be inclined to think that's the southern hemisphere version of a tropical upper tropospheric trough that it kind of ends up benefiting from. So really good, very widespread outflow, northwest, north, northeast and southeast directions. It's a very divergent environment, and the associated coastline I'll mention once again will be very, very beneficial for Genesis in this area, alongside the very, very, very warm waters that are around here. We're looking at 31, 32 degrees here. So very, very suitable conditions for tropical cyclone genesis. If the low from the monsoon trough becomes dominant out of 10 and 11U. Then it moves over land. We see that, yes, very divergent flow again. We're looking at this kind of pattern here where we have a weak kind of trough here. That's passing. So it'll be able to benefit off that. But there will be some there will be some northwesterly flow coming in, so that may induce some shear. Overall, I don't think this is something to be having significant concern about, because we do need to note that it's already moving over land. It's going to be weakening anyway. This is just really to go into the idea that, okay, as it engages over land, engages within the monsoon trough, and ends up having this kind of a wind stress from the northwest particularly. Let's take a look at sounding. I think it'll give us a bit of a better idea. We'll take a look at sounding. Around, I won't be able to on ensemble, won't I? We'll take a look at the GFS, for example. Yes, the low goes inland. It broadens, elongates as it moves southeastwards. While it will have a benefit to that upper level divergence and that upper level divergent flow, as shown here, for example, with the wind barbs. So yeah, very nice flow that comes away from the system. Again, you've got that northwesterly flow. Vorticity becomes very scattered, disorganized, not typical of a tropical cyclone. And why that is will be determined by this sounding. 21 knot shear, very unfavourable level of shear. It's moving, well, if I took a good guess, probably moving at around 20 knots there. So if again, take a look at this broad environment, we see that this shear is, it's simply not conducive. It's more westerly to begin with, where it's not moving. And in general, overall, I think we should note that while there is northwesterly kind of flow, I think we'll have a kind of better idea. This northwesterly flow is, it's not a matter of it being too strong, it's a matter of it being too weak. We can see that there is flow there, it's moving, it's kind of an easterly flow that that is actually noticeable on the soundings here. Let's take a look again. Yeah, we see that generally with height, it increases obviously as it interacts with the jet, and the upper level divergence as a result becomes of that. winds are actually fairly weak. It's moving fairly quickly southeastwards, accelerating as it gets picked up by that trough that I was discussing off the coast of New South Wales, and it's weak. If it was moving at around 20 knots, we'd have to see winds generally be aligned at 20 knots for the shear to be most beneficial, for it to all be aligned. But if we look at 700 millibars here, winds generally weak. They do somewhat increase as we go up, but this pattern is not favourable whatsoever for Genesis, as we see that these winds are not catching up with the speed of the systems going up. So there will be a disorganization in the convection. The convective structure will not be able to get together. What should be more important as well is the fact that the relative humidity values across this general area are quite low. I may have created a bit too much of a big box, but if we look at the relative humidity plot, we'll see that, wow, with the shear that ends up obviously being around, and first of all, there is shear, a big shear, it moving very quickly southeast, and trying to keep its convective structure together. It won't be easy, as we see here. That main convective mass that's evident with the bulk of the relative humidity values, we see that it's moving so far quickly southeastwards, while the kind of main low is struggling to keep up. Hence, with this shear, you see lots of dry air from the Australian desert, and just the general land over all this over on. Really easy window for the dry air to kind of entrain in and cause problems. So, no brown ocean effect here, despite it being fairly common around this time of year, as the Australian mainland can be beneficial if the conditions are right. It's just unfortunately not likely to be this time. And obviously with the European solution, we see that this is not going to be happening, as we don't see a low develop northeast of where 10U is, and instead that low is dominant and stays over water. Now, as we've taken a look at the environment with the GFS solution, I want to now obviously give the same kind of treatment to the European and the Canadian potential as well. Let's analyse this. So, although it's a very broad low, the overall upper level setup, where 10U roughly is around here, is generally favourable. We're seeing it broad upper level anticyclonic flow that's embedded within. So overall, in terms of the upper level 200 millibar flow, fairly conducive, weak upper flow, divergent broadly divergent. So it will be able to benefit off this in that regard. Even here, weak but divergent to some extent. It's around. And even up to hour 144, we see that yes, there is a pretty nice upper level pattern. It's not the best, it's not top tier, but it's somewhat favourable with the fact that the upper level flow is generally weak and broadly anticyclonic, so there will be benefits to that. Obviously, I should not need to note again. In fact, I might go look into it actually. That's the different 90S that I should not be looking at. Perhaps cyclonic weather is not updated. But let's look at the SST analysis here and into the I don't think they have an area for the Indian Ocean. Might have it. See. You'll barely be able to see it. I think the Southwest Pacific has a better view. Yeah, there you go. Right, so this does extend further that way. If we do look, that does extend that way. But you see these waters very hot. These colours we're looking at 31, 32, particularly where the GFS has Genesis. There is that very nice environment, a very nice spot 32. 32, 31, widely prevalent further west as well. where the other models have 90S as dominant. So it's very favourable oceanic potential. I should note that if we look at the Indian Ocean there, specifically in this part, you may already be noticing that it's very, very, very hot, anomalously hot. We're going up at like up to 4 degrees, anomaly really positive. So very above average waters, largely above average waters. That's why they're so warm, and they will contribute very largely to tropical cyclone genesis if other conditions are right. But it is broad. It is broad, and it will struggle regardless. So that will introduce difficulties. But yeah, very above average waters there. Just thought I'd note. And that's why we're seeing 32. I think 33 might actually be a possibility in some spots. That's how warm this area is. Very shockingly above average, and will be beneficial for the system if it ends up developing a more tighter structure. There will be more, I guess, benefiting off this oceanic potential. Let's look at soundings though. So obviously we know that the general upper level pattern, not very, but more so quite conducive noticeably as it's in this broad anticyclonic turning. And the oceanic potential is fairly good as well. Obviously we've analysed, maybe fairly shouldn't have been the term that I used, because in fairness it's very good. But let's take a look at the kind of soundings to have a better analysis of the actual wind profile. First of all, we're looking at 90S here, tropical low 10U as its own low with its own integrity here. And that's what the GFS soundings obviously caught onto. We will not be able to get a better view on the other system, at least not on the GFS, because we are not tracking that low. That's a separate low that develops on further east along the monsoon trough. So this isn't really. We'll have to be looking at the environmental conditions for 90S as it exists on the GFS for now. And we can see that overall, elongated low, with a wind profile that's not the best, generally fluctuating patterns, it's not really moving in a particular direction, so whatever flow we generally have, for example, we see that it's generally erratic, it's not moving in a particular direction, and the flow does widely change, varying kind of flows by the hours. The flow is not really consistent, and at the current time that we're at, we're currently 1 hour past 6 years at the time that I'm recording this. The flow, it's weak, higher than 500. Overall, it's a very complex kind of system. If we look at the vertical analysis of the barbs here, we got some easterly flow there, some westerly flow there, no flow there, northerly flow there. It's a very complex pattern. Although the winds are weak, varying directions will still introduce some level of complexity, and it won't necessarily be extremely favourable. This kind of complex pattern, it becomes a little less complex, but still we're seeing southerly flow in the low levels, 800, 900 millibars, basically nothing, and in mid levels really we're seeing persistent westerly flow. But in the direction it's moving in, maybe a slight eastward movement potentially, but I'm not really noticing much significant movement if we look here really. So, overall, while it may be trying to consolidate as we're looking at the relative humidity kind of structure there, it's struggling. And what makes it even worse is that, not even considering the kind of pattern that we have here, particularly the upper levels, there will be some noticeable shear, but that's not as big of a concern when we realise that obviously it begins that kind of interaction with the other developing low in the monsoon trough, aka 11U, which eventually becomes dominant on the GFS. So, for the GFS, in that regard, it's an outlier. I think I should note it is an outlier. And I think the ensembles are generally very, the ensemble I should say, and its ensemble members, I think it'll be worth taking a look, are generally quite split in terms of whether it develops there or whether 10U becomes dominant. We will have to take a look. I've completely lost myself in this regard, trying to find the GFS. Yeah, as we can see, very split. We see the majority of the members have 10U as its own low. Some keep it as its own low. But there are varying members as well that do develop it around this area, closer to Kimberley. And overall, no organised track structure. Even like looking out 5 days out, usually GFS would have a higher concentration of members if there was higher confidence in the genesis, really. But no, very split overall. No kind of real particular track that is being taken with these ensemble members. Compared with the EPS has higher confidence with Genesis coming from 10U, and there is actually very little confidence in any Genesis along the Monsoon Trough further east, and they're all focusing on 10U specifically. Despite it being broad, a lot of the members do deepen it and do actually intensify as they begin to go southwestward, so it's actually fairly interesting how much confidence some of the EPS members actually have, if not most of them really. It's really interesting to see. And obviously if we take a look at the Canadian as well, a little bit more broadness, though they have less members so it doesn't look really clear, but yeah, they do still focus on 10U largely as its own low. Varying times of movement southwest, but I think, and some do actually develop along the Monsoon Trough as we see here on its eastern flank there of the main ensemble member chunk there as we're looking at it. Some do develop it along Gibberley and do move it southwest, but generally 10U still holds the kind of majority along the GEPS ensemble there. In terms of the environment for the European deterministic, as we see, very broad low. That's kind of why I got surprised with a bunch of the EPS members going so strong. The deterministic doesn't intensify it that much. Well, it does deepen to 993, but that's still way too broad for a tropical cyclone. Very broad structure. Let's even look at this. Like, this is clearly a very disorganized structure. The kind of precipitation rates give us an idea of the convection. Relative humidity also provides us a nice structure. It's broad, very heavily broad, and it will not work overall. But evidently though, as we see the wind barbs kind of coming closer together gradually, as it intensifies, it does attempt to tighten. So maybe as it heads southwestwards, let it down in the period, we could see potential tropical cyclone formation later down the line. Now, in terms of, because now we know that the European solution has 10U as dominant, or 90S, we'll be able to take a look at its soundings a bit better, and although I don't think I can because they haven't really, they haven't loaded in it, let's take a look at manually plotted soundings, which I'll go into now. And we'll actually be able to track the system, because it doesn't actually end up dissipating by 5 days. Because GFS thinks it's okay to develop another system, but yeah. See here, got that system lasting all its period. Let's take some soundings to evaluate its environment. So, let's take hour 60 as a first kind of point of analysis. This will be 48 hours from now, or maybe a bit less from the time I publish this. We take a look here, and overall, kind of conducive. The overall deep layer shear is only 9 knots. The relative humidity, as expected in this kind of environment, and as being kind of a lonely kind of system that's struggling to develop, we know that relative humidity is going to play a bit of a part in kind of how it's struggling to develop. But the overall shear environment, I'm seeing at the kind of left side of my screen, this system is moving eastwards. If you guys can't see it, that's kind of where I'm looking. And that aligns with the bulk of the flow, so we're looking at easterly flow going mainly under 200 millibars for the most part, and a good chunk of the kind of levels, also evaluating here, is generally westerly. So it will align with the fact that it's going eastwards, and it will align, so this kind of environment isn't too bad. We must also take into account relative humidity levels are kind of poor, and the structure that we're evaluating will take time to organise, especially as it tries to interact with the monsoon trough. It will have periods where it will struggle because it will have to try and tighten up and become sufficiently organised for tropical cyclone standard. But overall, the upper level pattern here doesn't seem too bad, and you know, if the system was better structured, it could get away with developing in this kind of environment. Now let's go for 0.72. So I think this will be hour 60 at the time of recording. That's I'm trying to think if that's too big of a box. Let's take a look. Okay, that's fine. Yeah, again, very similar pattern. Above 200 millibars, it's not really too big of a concern. The main focus will be around 200 to 850, and overall they keep it the same, very similar. Obviously there is no particular consistent path eastwards though. So while it may make slight nudges eastwards, the low itself I'm on about, you know, it will be more erratic than what I'm saying really. But overall, the shear westerly continues to be very westerly. So if any easterly nudges are made and it tries to move eastwards, shear upper level conditions are overall really conducive, and will be suitable for Genesis if it does try it. And this is kind of the situation where it can't do Genesis because, as we see, it's merging with the monsoon trough vorticity and it's kind of engaging within it now. So any Genesis and any attempts at tightening up its structure and trying to get better in that regard, it doesn't work. It just broadens out and it broadens out. It cannot use its conditions to its advantage. Now, once we have a bit of a more coherent low, which actually doesn't have to deal with any external factors like the monsoon trough interaction, let's now take a look at the sounding. Now it's going to be a really big sounding, very broad sounding as we take a look at the broad system. And overall, conditions quite suitable. So even though it's a broad system and it will naturally just take time to try and tighten up and actually gain a good solid convective structure for classification, we'll have to see now that overall it will be able to take its time, at least from what we can see, because the upper level conditions are actually kind of good. Again, predominantly northwesterly flow as it moves southwest, so sorry, should I say northeasterly flow. And while it moves southwest, that's very conducive overall. That negates some of the shear that ends up being prevalent. And hence we got only 6 knots of deep layer shear there. And what's also important is that the relative humidity values have actually increased in the sounding and are now sitting at 81%. So, quite good overall hodograph pattern. You see northeasterly flow for generally most levels, and the winds are quite weak, so as the system moves fairly slowly and at the rate of the shear, overall I think the environmental conditions might not be something to worry too much about. What will be more of concern, and what should be, is the large size, and that will be a bit of a concern to tropical cyclone Genesis. That's why it might be good fairly if going out and analysing the potential for development in the long extended outlook coming up to 7 days. If it may be cautious given higher chances when we understand that there are several kind of modes to be focusing on that may prohibit genesis or at least delay it. Overall summary, sorry. Overall kind of summary that we have here. The low is currently okay. It's not really showing any signs of organisation, and it will take time as it begins to engage with the monsoon trough, and it largens. It definitely does get broader, but the overall environmental conditions will be favourable. So when it does want to take its time and it does want to end up finally developing later down the line, later this week and into next week, as it wants to try to develop, it will be able to probably do so, tightening up, strengthening, actually getting coherent vorticity lobe within the middle of the kind of low, and yeah, and eventually getting organised to potentially become a tropical cyclone. While it is broad and deterministic, and there is reason to believe it will be broad, that's why I'm saying be cautious with analysing the potential. We do see, again, let's look at the ensemble members here. Very large amount of them do intensify the system quite a lot. So potentially, maybe what the ensemble members may be suggesting is that the monsoon trough interaction may not have such as big of an effect as what is shown on the deterministic. It might be able to stay tighter, closer to how it was in the beginning, closer to how it is now. If it stays tighter, it will definitely have a higher chance of tropical cyclone genesis in the beginning, like some of the ensemble members here are showing. So we could potentially analyse the potential for this kind of scenario to play out. There's actually quite a lot of ensemble members which are suggesting this. There's been very high confidence and consistency really for this kind of evolution from the ensemble for many days now. So we must also not rule out this potential. And in regards with the American solution and its ensemble, I do not think that we will be getting any kind of development there. There are very little confidence overall in that, especially when there's very little confidence in its own ensemble, in the GFS ensemble. Very little confidence in that. I think, the kind of genesis of 11U over there should be taken very lightly. I don't want to say it's like completely impossible, because in meteorology it's very difficult to say that. There's always the potential for development up here, but with what we're seeing, most of the development potential on the models at least is it's shown to be it's shown to be more favoured to be closer to 10U, and overall the kind of environmental conditions up here will be less favourable as previously analysed. And there's just more overall to suggest that there will be a more dominant low here at 90S than 11U, which could develop along the monsoon trough. There could be some sort of low that develops here, and there will be kind of a bit of a more active monsoon trough overall later down the line. I don't rule that out. I actually do think it will happen, but it's more to suggest that there's a lot more guidance, consistent and enthusiastic about low 10U developing there. So my personal opinion and my personal view and analysis, I would say this area, Western Australia, this area is the place to look out for, with 10U specifically as the system that will be of interest in this area. In general, the Australian region, if any development's going to happen, it will be this. And overall, very important to just keep looking, monitoring the structure, because the structure will be the main hindrance for many days. The environmental conditions are overall conducive. If, while engaged in the monsoon trough, it can stay tight enough, it will have better chances of development earlier on. But it can also still tighten up and develop later on. The environmental conditions should be overall quite conducive throughout the way. I think it will also be useful, because we did see some low relative humidity values earlier on. it is trying to keep itself together there, but given it's a weak system, and there is dry air within the proximity, it may still be allowed to get in somewhat. So, with the fact that it's struggling to kind of develop right now, you know, dry air will be kind of a hindrance as well earlier on. That might actually be part of why it's struggling to develop. But what does solidify the kind of idea that it won't develop early on is the monsoon-trough interaction there. Thank you for watching. Kind of a long video here, trying to go over the kind of specifics and trying to dive deep into tropical cyclone genesis potential north of Australia. I hope you guys found this useful and informative. Let me know down in the comments what you think, your opinions. This is my third video kind of going over technical tropical cyclone weather, all that kind of stuff, and doing deep analysis videos. Yeah, let me know what you guys think, and I'll make sure to be back later on with some more information, especially regarding Dicklady, as I did not get a video out yesterday. I thought that I might actually think that it might be a bit of a good idea to give a bit of a summary now. It's in the Mozambique Channel now, I think, or moving in, and conditions should be fairly conducive for some decent intensification. But yeah, I hope you guys found useful this more focused kind of analysis on tropical cyclone genesis potential in the Australian region regarding 10U and 11U. And yeah, that's really all from me. Focus on 10U. There's more chances with this, more potential with this. I'm pretty sure the American GFS solution will probably be able to. The overall model will probably be trending closer to 10U. And 10U specifically. So that lowers of interest. I do see chances slowly being increased by the Bureau for 10U. Obviously we're seeing that now. They are noticing that, you know, chances are increasing for 10U, hence they've increased the chances. But they've also increased chances for 11U. I'm not sure why they've done that. In my view, at least, I don't think that it has really noticeable potential. But it will be important to keep monitoring the model guidance over the next few days to actually see what they think, what the kind of models are anticipating. As things can change, there is still quite a lot of lead time left, still quite a lot of time left before anything forecast is supposed to be going down really. So keep watching, keep tracking, and I'll keep you guys updated as well when any new significant information comes out. Thanks for watching, guys.